to all of my wonderful parents. This is Miss Wright. Thank you so much for taking the time to watch this quick video. I wanted to take a short poke to hop on here and get you guys involved in what your kiddos are up to in math right now. I am first going to start with a problem that was posed in class last week. The problem that was posed to your students was to find the amount of time that has passed between 5:35 p.m. to 9:17 p.m. How much time has passed? 5:35 p.m. to 9:17 p.m. There are a few ways a problem like this can be solved to find the correct answer. Amongst your kiddos, counting up was the most popular strategy. Counting up is where you count up from the smaller number to the bigger number to find out the distance between two numbers. This is called difference as distance. They find the sum of the distance between the two numbers to solve this problem. Here is an example to help you better understand. Alright, here is our first example of counting up. In this situation, the student added 3 hours to get to 8:35, 25 minutes to get to 9 o'clock, and 17 minutes to get to 9:17. And when we count up, it's important to remember that we have to find the sum of all the chunks that we added to find the total distance between our beginning time and our end time. So what did we add? We added 3 hours, we added 25 minutes, and 17 minutes. When we add all of those together, 3 hours plus 25 plus 17, we get 3 hours and 42 minutes. All right, it is also important to remember that counting up doesn't have to be done in just one way. There are many ways that we can count up. Here is another example of how a student counted up when given this problem. In this example, the student added 4 hours to 5:35 to get to 9:35. Now we run into a problem here. 9:35 is bigger than 9:17, so that's too much time that has passed. So what the student did here was they figured out the distance between 9:17 and 9:35, 18 minutes, and subtracted that to get back to 9:17. And in that way we have 4 hours minus 18 minutes because we add the total sum of the chunks that we added to get the total distance of 3 hours and 42 minutes. This strategy is a wonderful way to solve a problem like this, but the strategy that I want to introduce to your students now that they have mastered counting up is regrouping using base 60. What worked best with the students when I taught this base 60 regrouping was to make a parallel to base 10 regrouping. Let me explain here. So when we're using regular numbers, like 23 minus 17, we can use counting up like shown before. 17 plus 3 is 20, plus 3 is 23, and the total that we added is 6. Doing this counting up method is sometimes easier for your students because they can break up the total distance into chunks that are more manageable. Or we could subtract using vertical subtraction. But when we subtract 3 minus 7, we must regroup. Otherwise, we'll get a negative number and the wrong answer. So when we have 23 minus 17, we first have to borrow one group of 10 and move it over to here, our ones place. So that means that we're adding 10 ones because one group of 10 is 10 ones. We add 10 ones to the ones place to get 13. And then we can subtract like normal. 13 minus 7 is 6. 1 minus 1 is 0. And here we get our answer of 6 as well. We can do this same regrouping with time, but it is important to point out that time is not in base 10 like regular numbers. Time is in base 60. This can be confusing for us because we are so versed in regrouping with base 10s. When I first gave your students this problem and asked them to regroup, they wanted to use base 10, but realized quickly that it wouldn't work. When we are going from 5:35 to 9:17 and trying to find the total distance between the two, we can write it as 9:17 minus 5:35 to find the difference. So, in this problem, we must regroup because you cannot subtract 35 from 17 without getting a negative number. In time, we can't have negative numbers. So what we do is we take an hour from the hours place and we can shift it into our minutes to have enough time to subtract 35 minutes. So when we do this, we have 8 hours because we took away 1 hour, and we're adding 60 minutes. This part is what can become difficult for your students and for us as well. We are so used to adding 10 minutes or 10 from our tens place to our ones place, but in time, we aren't using tens place and ones place. We're using hours place and minutes place. So it's very important to remember that when we're subtracting an hour and converting it into minutes to have enough minutes, we're actually adding 60 minutes. And when we add 60 minutes to the 17 minutes that we already have, we have 77 minutes. 8 hours and 77 minutes minus 5 hours and 35 minutes is 3 hours and 42 minutes. We borrow 60 minutes when we borrow an hour, the same way that we borrow 10 ones when we borrow one group of 10. I hope that this is starting to make sense. If not, no fret. I am here if you have any questions, and we are going to go over more together at the end of this video. Here at the end of this video, I have given you some problems that will be beneficial for you and the student to try out together. There is no trick or shortcut to learning this skill, except good old-fashioned practice and just a constant reminder to consider what base we are in. I suggest asking your students questions to remind them that we are in time, such as, are we borrowing a 10 here? Or are we borrowing an hour? Or how many minutes are we borrowing when we borrow an hour? Is this tens or am I in time? If I am in time and I borrow an hour, is it 10 minutes or is it 60 minutes? As your students practice, they will be able to train their own thinking, not only to subtract time, but they will develop a deep understanding of why it is done this way. You will probably encounter many different responses from your students as you practice these problems. One possible response is that your student will try to use base 10 as they are developing the shift into base 60. This suggests that your student is completely normal. There is nothing to worry about. They are so familiar with base 10, and that is why this practice is so essential. It is important to just guide them towards base 60 using the questions I suggested before to promote inward thinking. Another possibility is that your students may also try to continue using the number line / counting up method. This is okay, and encourage your student to use this method to check their answers, but we really want your student to begin shifting to base 60 as it is important for their deeper understanding of subtraction of time. Thank you so much for your time. If you would like to end the video here, that is okay, but if you would like to try out one more together, I would love for you to stay. Alright, for our last example, we have 1032 to 1104. So we know that we're trying to find the difference between these two numbers, or two times. So we'll do 1104 minus 1032. Immediately we can see that you cannot subtract 32 from 4. You cannot subtract 32 minutes from 4 minutes without getting a negative time, and we don't have negative time. Alright, so what we can do is borrow an hour from our hours and put it to our minutes. So we take away 1 hour from here, and we have 10 hours, and we're adding an hour to here, or adding 60 minutes. Remember, not 10, 60. So we have 10 hours and 60 minutes, and we add our 60 minutes to our 4 minutes to get 10 hours and 64 minutes minus 10 hours and 32 minutes. When we subtract, we have 10 hours minus 10 hours is 0, and 64 minutes minus 32 minutes is 32 minutes. And like I said before, you can go back and use that counting up method to check. I'll show that here. Here's how we can use the counting up method to check our last problem. So we said 32 minutes was the difference between 10:32 and 11:04. When we add 30 minutes, we get to 11:02. And from 11:02, we add 2 minutes and we get to 11:04. I appreciate greatly you taking your time for this video today. If you have any questions, please feel free to reach out. Thank you. Have a wonderful day.